Hello, everyone. Hello, YouTube. Hello, Professor. I'm here to present my final project for MC310. So, let's see. All right. So, hello, everyone again. My name is Ian Chambers. I'm currently a junior mechatronic engineering student at Vaughn College in New York, Queens, New York. And first final project is for my fundamentals of mechatronics class, where I've learned a lot about coding with Python, as well as learned about the ROS2 operating system for simulating robotics physics, and about my final. Just a little bit of introduction before my final. So during our class, we learned about Python, which is a high-level coding language that has been used all around the robotics industry because of its simplicity as well as its um, abilities with data science, AI, and automation. And as well as ROS2 has been used across the industry because it's an open source platform where you can simulate and design robots based on physics in the real world. And these two work together because in Python you can actually create classes or create robot logic. And you do this by importing the ability to create nodes. So you can import the library from ROS2 itself, which allows you to create nodes, and based on the their major class of nodes subclasses. And you can also create import messages that allow ROS and Python to communicate, which you'll see later that I have done for my project, as well as using topics that subscribe, which is sending, or subscribe, which is receiving data, as well as publish, which you'll see I've done. Publish data, which is sending data to the data distribution service that ROS2 has. So basically, ROS is kind of like the middle manager between the nodes and Python so that we can communicate for the simulation services. And Python itself is a language that I use to write and run the nodes. All right, so my task was to use, my task was for ROS, dealing with ROS Gazebo. So in ROS, we learned about the Turbot 3, which was used in the Gazebo simulator, and I was tasked with simulating into this house world in Gazebo with a Turbot 3 robot and autonomously guiding it to its position from starting from outside the house. You see this arrow? It's going to be outside the house, has to go into the house and under the dining room table for its end goal. And this all had to be done using Python code and make it move autonomously, so I didn't have to control it. So my approach was to go over the code that was shown in class, the later classes, and see how I could adjust that and use it for myself. So going into the code that I used, or that I did, so the first thing I did in my code was to import some libraries and messages so that I could use that for my code to communicate with the robot. So the first library I imported was the biggest and most important, really. So that's the ROS2 Python library, which allows or has a lot of different commands and things that you need for Python and ROS2 to communicate. So what I used from the library was specifically the node class, So the node is gonna allow me to. A node is something that performs a specific task, and to for me to create that node to allow to send the data for the robot to do the task that I wanted to do, is I had to get the base node class from the Python ROS library to subclass it for my child node. So then I also got the geometry messages and imported from that the twist messages, which allowed my robot to communicate its, or my Python code to communicate its velocity commands in linear and angular directions. And I also got the duration class from the Python library because it my code is more of a time-based code, and it allows ROS2 to add seconds to the clock, and it's going to make my time-based code better. So next thing I did was define my class slash node. So this class that I'm creating is a node, and it's going to be kind of like a child of the parent node, because it needs, as you can see, my class rotate and drive has the parent node in it, so ROS is going to know what I'm trying to do with it, as well as this super init is telling that basically telling ROS that to register this rotate and drive name to the DDS, so that it allows communication, it allows publishing and subscribing, because the DDS is kind of like a history log of where all your nodes go, so that it knows what it's publishing and subscribing to. So let's go back. Next is kind of more of the hard code that I did for the robot, as well as different things I did with the publisher. So this first line, the self.pub, is me creating a publisher on the CMD vel topic which is created. So the topic is going to be sending data to ROS2. So it's sending specifically twist data, which is what we imported from geometry messages. So twist is the velocity commands for the robot's linear and angular movements, and this is going to, what I learned, going to be sent to the QoS, and this 10 is for the QoS Q depth, which is basically kind of like the max amount of data packets they can send at a time, so that it moves consistently and it doesn't break. So this publisher is going to be sending 10 data packets at a time to the router, so that it continuously communicates. So next, my self.sequence list has about 10, 12 tuples that represent the linear and angular velocities, as well as the duration of what is going on, the segment that is going on. So this is what I did coded to move the robot forward, left, right, from the position that it originally was in to the position that I wanted it to be in. So that's a pretty self-explanatory. So now, going deeper into this code is where I created the self.segment index. So it just tracks which tuple or which line is currently executing right now, and the deadline immediately starts the list, so that it's not able to read, but it starts the list so that the row is able to move. And here I created a timer, so that on a 50 hertz repeating timer, which it allows for controlling responsiveness of the robot. I did have problems with the robot not responding Specifically to this forward movement, this forward command, it would not move until getting to the next command after that, the turn left. So I learned about this. So continuing the code, I have this loop callback. So object in the loop object, I'm sorry, I have the now variable, which is telling Ross the current time, and we can see going back and forth between these two. With this if statement, the now variable is checking if the deadline, which shows when the next sequence should end. So these lines are going to be my sequences, and this is telling when the next sequence should end. And if the time now is greater than or equal to the end of the next sequence, then the index segment, which advances to the next iteration, is going to show, or it's going to compare itself greater than or equal to the number of sequences in this list, the self.sequence list. And if it's greater than, so meaning if there's no more indexes to iterate, then it's going to basically destroy it. So it's going to destroy the node because the robot no longer needs to move. And what I'm doing here in the next code is creating velocity commands for the twist. It has, as I mentioned before, linear and angular commands, and I'm allowing it to publish the command at the segment start. So that's going to be up here, I believe up here. And then after, this is for just initializing the libraries. So this allows the ROS2 Python to start, which is probably the most important thing here. As well as I have instantiated the node, so for rotate and drive, and that's going to be used also in the spin node. So that's cleans up and exit ROS when spin returns the destroyed node. So this is basically shutting down when I tell it that I'm stopping it. I'm just going to shut down ROS. And now we need the if. This is for every code, if name. So just make sure the code only runs when it's executed. So now that's going to be all of my code. The time, I'm basically overview, I created a time-based code using the ROS2 Python library. I imported nodes to subclass, as well as the geometry messages. I imported twist for my angular and linear velocity, as well as duration to better my time clock, or time-based code. Now, I'm still sharing my screen. I'm going to simulate. Again, thank you. Now to the simulation. I'm going to simulate my code step by step. So I'm going to start from the beginning. We have to in the terminal and copy this. Got a lot better. So now we have the ports. We're connecting to the port. Alright. So there are a couple technical difficulties, but now we're good. So I'm going to show you the simulating the robot. I've signed in using the GitHub, our professor's GitHub, and launching ROS2 and launching ROS Gazebo, the house. And we have the robot outside the house, and now it should be navigating itself to under the table. Let's go. You see it using its sequence, starting. Sorry, move forward. See, it's moving somewhat, I would say, jittery. And that might be because of the hertz or uh, the the for the publisher, the QoS only at 10. Maybe it needs more. I don't. That would be something I go into in future projects. But as you can see, have it navigate up to the doorway and down to the table. Successfully got under the table. Unfortunately, I'm on a laptop, so I really can't like. Let's see. I can move in. You can see, try and see under the table. Well, we know that's under the table, and that was my code. The code shows that it's shut down and knows that there are no more segments, and the time for this length of the sequences are done. So it destroyed the node and shut off. And that is about it. Thank you for watching my presentation, and have a good one.